So we were on these problems yesterday. Our directions were just to find the derivative. If I have a specific value I'm finding the derivative at, then I have an a I can plug in. But these, we are just doing the generic find a derivative. So we have the two definitions. You could use either. I really favor this definition. The limit as h approaches 0, f of a plus h minus f of a all over h. So if I'm going to do that, we have the limit as h approaches 0, f of a plus h, so I replace my x with a plus h. Minus f of a minus a all over h. All right, from here, any thoughts on what we might do? The conjugate, that will help. I will say, since if it weren't in the denominator, I would 100% go with that option. Since I do have two terms up here and they're fractions, let's get a common denominator first and then see if we need a conjugate. So this one would have to get multiplied by 1 minus a on top and bottom. And this one will be the 1 minus, could I just write 1 minus a minus h? If I distribute that negative. For radical 1 minus a. Denominator is kind of ugly. Can I just go ahead and put these fractions together? Is that okay? You know they'll have the same denominator, and my denominator is just both radicals. Okay. Very ugly. At least now I have one fraction on the top instead of two. Can I cancel my h's yet? So what do you think now? Now let's go with Cole's suggestion. This is going to be extra beautiful, isn't it? If you guys are okay with it, could I, since both of these have the 4, could I just factor that 4 out? And then that gives me a little bit less to multiply by than my conjugate. I would just have to do radical 1 minus a plus radical 1 minus a minus h. Does that make sense? Okay. Pretty ugly, but I think we are close to getting better. So I have my 4. When I multiply those by the conjugate, I have 1 minus a minus 1 minus a minus h over all of this mess. You could multiply it out if you wanted. I'm not going to. That whole thing was divided by h. That's like an h over 1, so we could flip and multiply by 1 over h. So now we no longer have a fraction in fraction. So it's better. we are really close now. On the inside, if I distribute my negative, my 1 and negative 1 cancel, my negative a and positive a cancel, so I just have 4h on top. Now what happens? Almost, except this gives me a 0 on the bottom. And h on top and bottom. Those cancel. Now we can plug in our h finally. So we just get 4 over radical 1 minus a times radical 1 minus a, radical 1 plus a, or sorry, 1 minus a. Plus radical 1 minus a. So if I multiply the radical 1 minus a's, it drops the radical and we just get 1 minus a. If I add them, that's 2 radical 1 minus a. 4 over 2 is 2. This is like a 1 minus a to the first times a 1 minus a to the 1/2. So if you multiply those, you add exponents. This would be a 3/2 power. Definitely ugly. This one had all the ugly things in it. It had the radicals, it had the fractions, but we were still able to eventually get to the end. Anytime your problem has a radical, you'll probably have to multiply by a conjugate at some point. If your problem has a fraction, you're probably going to have to get a common denominator. So this one we had to do both. Did I lose you guys on that one? Last problem, one final problem, then you guys can just work and ask questions over what you need to. So a particle moves along a straight line with equation of motion s equals f of t, where s is measured in meters and t is in seconds. Find the velocity and speed when t equals 5 of this problem. So t to the negative 1 is 1 over t minus t. Velocity is asking me for a rate of change, so it's asking me for the derivative. If I'm doing this derivative, when as h approaches 0, what is my a value here? 5. Now, do you have to plug it in here? No, you could do it in terms of a, and then once you get to the end, plug in the 5. And if this was an ABC question where maybe I was asking to find velocity after 5 seconds and after 4 seconds and after 3 seconds, I would definitely do it in terms of a's. If you only have to find it at one point, you're welcome to go ahead and plug it in at the beginning. So we have f of a plus h minus f of a all over h. So if I plug in a 5 plus h, I get 1 over 5 plus h minus 5 plus h minus, if I plug in a 5, I get 1/5 minus 5 all over h. So if I distribute, this is minus 5 minus h minus 1/5 minus 5. That's what my numerator turns into. Divided by h, or you could put times 1 over h, since that was an h over 1. What happens now? Oh, that should be a plus 5 right there. 5's cancel. If I'm going to put all this stuff together, we have to have a common denominator. Okay, this one has 5 plus h, so the others are going to need a 5 plus h. This has a denominator of 5, so I'm also going to have to multiply the others by 5. So I'm getting a common denominator between all of those. So if I do that, get 5. If I distribute my negative h to that, that would be a minus 5h. Oops. Can I go ahead and distribute my negative h and this 5 at the same time? So that would be a 25 times negative h, so negative 25h. Negative h times 5, so minus 5h squared. Here, just multiply the negative ones, so negative 5 minus h. So my 5's drop. I get negative 26h minus 5h squared. What happens now?
The h jumps out cancel.
You cancel out 1h. And then we can plug in our 0 because we're not getting 0 on the bottom anymore. We have negative 26 minus 5 times 0, or 5 times 5 plus 0. So we get negative 26 over 25. That would be our velocity. So it's meters per second. The directions ask for velocity and speed. Velocity is just speed with direction. So speed is just the positive of this. So my speed is 26 over 25 meters per second. The velocity is negative to indicate it's going down at that point. Or in this case, it was a particle moving, so it'd be going backwards at that point. Speed is the absolute value. All right. Any questions for me? So the rest of the time, I want you guys to work on homework and ask me questions.